So welcome. It's not going to be the most exciting talk like Neil's from 2 weeks ago, but I thought I'd talk about the Rule of 70, which I do cover and use a little bit every once in a while in my everyday life, although every day is probably a little misleading. So what is the Rule of 70 to begin with? It's a math formula that estimates how many years it takes for a quantity to double in size given its annual growth rate. So our brains are kind of hardwired to figure out how things double. It helps us, I give you a percentage, it doesn't mean a lot, but if I tell you it's going to double in 5 years, that means something more to us. So that's kind of one of the reasons why the accountants and stuff like to think about the rules of 70. So brief review of some concepts we're going to need for today because we are going to derive a formula here. Functions show relationships between two quantities, and so the function that we're going to start off with shows the relationship between time and how much money you have invested, and then we're going to use that function to come up with a new function which will give us the doubling time. Inverse functions cancel each other out. And what do I mean by inverse function? Like, I want everybody to get a number in your head real quick. Add 5 to it. All right, there's the function adding 5. The inverse of that might be subtract 5, and you ended up what? Same number, right? So an inverse function, they cancel each other out, and the two important functions we're going to look at today are the natural exponential function, f of x equals e to the x, and the logarithmic function, g of x equals ln of x. And you might have seen these before, and that might bring back bad memories from high school days if you did not like logarithms. But we're not going to do a lot with them other than we're going to use them to cancel each other out. And then I thought I'd put up here, here's the graph of e to the x. And if you notice, that has rapid growth. And that's the model that we use for exponential growth. And then here's the graph of ln of x, and I want you to notice it's the inverse function, and this is an increasing function. As x gets bigger, the y gets bigger. This is also an increasing function. As the x gets bigger, the y gets bigger. It just grows a little slower, and it's one of its cool properties. And if you look here, they have some symmetry through this line y equals x. That's how you can tell two functions are inverses. So for us, all we have to remember is those two functions are inverses of each other. So let's talk about the derivation of the formula. All right. So we're going to start off with the compound interest formula. And what is the compound interest formula? Compounded continuously interest formula. It is A equals P e to the RT, where A is the future value. So this is the money we want this is the future value of our deposit. P is the present value, or if you're old school, you might know it as the principal. R is the annual interest rate. And that's really what affects our growth. And time is in years. And E is Euler's constant. So it's a constant. It's 2.718. It's a lot like the number pi. It pops up all over the place in mathematics. So for us, we want to start off with this formula here. And we're looking for a new math formula that estimates how many years it takes for a quantity to double in size. So we want to know how long it's going to take for P to double in size, and that would be what? 2 times P. So we want to find the time it takes for P dollars to grow into 2 times P, and given an annual interest rate. And so we're going to let T sub 2 start off being our doubling time. So we're going to look for a formula for T sub 2. All right, substituting these values into the equation gives us the following. So all I did there was replace A with 2P, and I replaced the time with the doubling time T sub 2. And now we got to look for a relationship. Now if you stare at that equation, you'll notice one thing. And one thing you'll notice is the P's what? On both sides of the equation. What can we do with that P value? We can what? Divide it out. So what do you notice about the present amount? It turns out the P does not affect the doubling time. So we'll divide it out. So the nice thing for us is if you have $10 invested at a certain rate and Bill Gates has $1 million invested at a certain rate, you're going to each double your time in the same amount. He doesn't get to have an extra advantage just because he has more money. The only thing that's going to depend on is the interest rate. So now after we canceled it out, we came up with this formula here. And we have our 2 over here from doubling, and we have ER to the doubling time. And we want to come up with a relationship for this doubling time. So we need to get to it, but it's up there in the exponent. So this is when that natural log function comes in play. So just want to really point out the initial quantity doesn't affect the doubling time. The only thing that affects the doubling time is your interest rate. All right, so it's an exponent. What gets hold of exponents is the logarithmic function to get to that exponent. So, and just to remind you, these two functions are inverses. They cancel each other out. So it may seem like a little abstract, but all I did was I took that original equation up there and I took the ln of both sides. This side is kind of like adding 5 and subtracting 5. They're going to cancel each other out. So the ln and the e are going to cancel out, and all we're going to get left with is an r times a t sub 2, our doubling time. And now this allows us to solve this now for t sub 2. And how are we going to solve it for t sub 2? We're going to divide both sides by r. So we'll divide both sides by r. The r's will cancel on the right-hand side. And we come up with this formula here now. The t sub 2 equals ln of 2 over r. All right. If you're of a certain age, you remember what ln of 2 is. But only one of us is of that certain age anymore in this room. So in my day in high school, we had to know what the ln of 2 was. We had it memorized. So, because we used it for other calculations. All right, so how do we get to 70? Well, we have this formula, t sub 2 equals ln of 2 over r. It turns out ln of 2 is about 0.693, which is really close to what? 70. So they rounded it up. They said, hey, nobody wants to divide into 0.693. We'd rather divide into what? 70. It's a little easier number to work here. And so we can get this formula now, t sub 2 equals 0.7 over r, 0.70 over r. Now what's the problem with this? Well, first off, we're dividing into a decimal, and who wants to divide into a decimal? Nobody wants to divide into a decimal. Most of us don't remember how to divide into a decimal. You have to move the decimal point. So that's what we're going to do. We're going to move the decimal point. So we'll multiply everything by 100 to move the decimal point. Now, r is a percentage, and percent means what? Look at the percent sign. The percent sign really means divide by 100. See it? Divide, 2 zeros is 100. So if you've never noticed that before, that's what the percent sign means. And it means divide by 100. So if I have this divided by 100 and I multiply by 100, those like cancel each other out as well. So we're going to use a new variable here, big R, and big R is basically the percentage without the percent symbol. We just drop that percent symbol out. So this leads us to the rule of 70. And the rule of 70, it says the time it takes a quantity to double at an annual interest rate at r percent, big R, is approximately 70 over r. All you do is take 70 over r. All right, so let's look at what this really means then. Examples. If you average 10% rate of return on your investment, you get 10% on it. How long was it going to take to double? Well, what are you going to do? You're going to take 70 and simply divide it by 10. Your money would be doubling every 7 years approximately. All right. Used this one just recently. The Cowboy Joe Club, and I don't know if they realized that they were giving me a presentation out of this. They had a 110% campaign, and they were very sneaky about it. When Nebraska played Wyoming many years ago, the only way you could get tickets was to join the Cowboy Joe Club. So they got me in the Cowboy Joe Club. And then I wanted to keep getting decent tickets for Cowboy games, so I stayed in the Cowboy Joe Club. They had a 110% campaign going on, and so that meant what? We were increasing our money by what, 10%? And so my Cowboy Joe pledge in 7 years doubled in size because I went from that. So 7 years ago, I was given a $100 donation, and what donation did I give this year? I gave a $200 donation, so I could just say, hey, I did the 110% club and got the rule of 70 worked into it. So surprisingly, the person I was talking to did not know how to the doubling time formula when they called me up to ask if I wanted to renew my second year. So I had to teach them about the doubling time. So, all right. When I was hired here at Western, yeah, when I was hired here at Western, at that time we were averaging about 5% raises over the past few years. So if you average a 5% raise, you go to hire a company, they say, hey, we're going to give you a 5% raise on average over the years. How long would it take for your salary to double? You'd take 70 divided by 5, and that would work out to be about 14 years. So when I was hired at that dinner, when they told me, yeah, on average our salaries go up about 5%, they don't anymore. I could sit there and think, well, my salary is going to double in 14 years, so I'm not going to be making this piddly amount. I'm going to be making a decent amount. I just got to hang on for a few years. So, all right, inflation. Another place we like to look at this is what's the effect on inflation. So how long does it take for prices to double at 2.5% inflation? So what would we do? We drop the percent sign, we take 70 divided by 2.5, and I do not have this figure. Who has a calculator? $48? 28. I should have been able to, 28 years. So inflation is healthy to our economy, and generally the economists say around 2.5% inflation is what we want to be at. So on average, prices go up and generally about what, every 28 years. So you think about things, you know, a Coca-Cola back in my early days cost me about 20 cents, and now I don't know what they cost, a couple of bucks. And yeah, so they've gone up. All right. The U.S. inflation in August was 2.5%. So right now our prices on average are going up about what, 28, doubling in about 28 years. Let's look at some other high inflation periods. We had an 8% recently in 2022. So what's 70 divided by 8%? 27? 8.75. That sounds so. 70 divided by 8%. 8% is it? And I'm hard of hearing, so. 8.75. So when we had that 8% inflation, prices were doubling about 8.75. Take about 9 years for prices to double. That's why we started noticing it, is because even less, you know, it's still going up. Some other high periods of inflation. If you lived in the 80s, 8% seems high, but we've had higher periods of inflation than 8%. 13.5%. Let's see what that would be. I'll just grab a calculator out as well. So at 13.55%, come on, eraser. 70 divided by 13.55 in the 80s. We're doubling about every 12.5 years. That's a pretty high doubling time. So, all right, oops, all right. 1970, and I know most of us were not in the room around in 1970. I was around in 1970. I can tell you, I stood in, I didn't stand in line, but I can remember waiting in line for gas during the gas shortages of the 70s. And so we had a period of 11%, and that would be what, less than 12 and a half years. We won't crank it out. All right, so you might be wondering, this applies to all other countries as well. You can Google things and find out inflation at different countries. There's one country right now, I believe it's Argentina or Venezuela, that has like 200% inflation. Their prices are doubling so fast you're taking a wheelbarrow to go buy a loaf of bread.
There are a lot of issues due to their political environment. That's why.
Yeah, and the inflation is not helping the whole situation. So, all right. So I looked up what Russia was just yesterday. And Russia's currently at 9.1% inflation. So how long before prices double in Russia? Well, we take 70 divided by 9.1, and prices in Russia are doubling on average. And Russia, by the way, likes to have about a 3.5% inflation. So they're high right now. 70 divided by 9.1. Prices right now in Russia are doubling on average about 7.7 years. And that starts taking a toll on the average person. So when you think about that. So, and most people's inflation, when I looked it up, were around 2.5%, 3%. So, all right, and there's my sources in case you're wondering. I did cite them. So, all right. So in case you're wondering what does inflation look like, you can see right now, this has come down. It doesn't have the latest one. We're back down about 2.5%. This is the U.S. inflation from 1960 to 2024. And you can see we had some high periods here back in the 60s. Here was the 70s. This was what, 80s. Over here is what, 2022. So we are what, definitely haven't seen the highest inflation in my lifetime. And I always like to remind everybody, tough times don't last, but tough people do last. And so we can get through some high inflation once in a while. So, all right. Now, you might look it up. You might see there's also a rule of 72. These two rules have been around long before calculators. So the rule of 70, we take 70 divided by R. And if you Google the rule of 72, they take 72 and divide it by R. Well, this was the accountants at work long before calculators. 72 is an easier number to divide into because 72 is divisible by 2, it's divisible by 4. So back when we had to do these calculations on pencil and paper, the accountants used 72 over R if they wanted to estimate doubling time versus 70 over R. This one is what, more accurate because ln of 2 is about what, 70. So when you start seeing 70, well, what is 70? It's really ln of 2 times 100. So you might see other things where 70 pops up. So, all right, that was a little fast, but I'll open it up to questions. So, any questions? So maybe next time yeah, Rhonda.
Well, not quite a question, but I put on my history hat. And the topic that I used to teach about the highest rate of inflation was the Weimar Republic after World War I in Germany. You're looking at, in 1923, the inflation rate, I'm not making this up, I promise, you're doubling at every 3.7 years at 29,000%.
29,000%. That is huge.
Yeah, it's like $1 million just for a loaf of bread.
Yeah,
And
we're
that,
looking at people wheelbarrowing.
yeah, and that's what happened to the the Soviets. They hit inflation in the 80s as well. U.S. was going through high inflation, but Russia was going through a much higher inflation. You had to take a wheelbarrow in to buy a loaf of bread. So, all right.
Also in your lifetime, Chuck?
That was also in my lifetime, yeah. And your lifetime too, I think, Bill. Oh, I forgot you were here. Did you ever stand in line for gas? Were you ever?
In the early 70s.
In the early 70s?
When I was
with your parents?
10 years old, I did not stand in line for gas at 10 years of age. But I was in the car when my parents were in line for gas.
Yeah.
Yes, I do remember that.
Yeah. So interesting times. So, All right.
only certain days you could go get gas based off of your license plate number or something like that.
I don't know if that was the case in Iowa, but I know
LA was like
LA was that. You had to go by.
the lines going out the, into the street, and my dad cursing a lot.
Yeah. So yes, those who've never experienced waiting in line for gasoline, it was an interesting time, the 1970s. So, all right. Well, if there's no other questions, thanks for coming today. We have a